Now what we did, we started with this matrix and asked everybody to come up with a matrix that would row reduce to this one. And it's very easy to do that. We just add rows of this matrix to one another and keep adding rows of matrices to one another, and we get a matrix. This is the one I got, and as it turns out, I think I messed up, as I found out at the very end. So, question that we're going to approach this is a question of whether this matrix reduces to this. Okay? Now, of course, we could reduce the matrix and find out. I think it's one little glitch in there. However, if this matrix reduces to this, the basis of the row space is this. Because all we did in getting this matrix from this one, and all we will do in getting this matrix from this one, if this is the right matrix, if this is a correct matrix, is adding rows to one another, adding multiples of rows to one another, and perhaps multiplying rows by some number, and switching rows around. So, if I did that correctly going from here to here, then the reduction is going to work. Okay, and in this case, the basis of the row space. Now remember, the row space is the set of vectors in the row. Okay, so the row space would be the set of all vectors that you can get as sums of multiples of these 5 rows. And since this matrix reduces to this, it follows that the row space, I was going to say something else, but I'm not going to. The row space is a sum of multiples of these rows. Okay, the sums of all possible, all possible sums and multiples of these rows. But of course, there are only 3 non-zero vectors here, which tells us that these vectors are not all linearly independent. Okay, so in any case, the basis of the row space is then just these 3 vectors. This row, this row, this row make up this vector, and this vector. Basis of your column space is, well, without explanation, each row that we get in the reduced matrix, each non-zero row will have a leading 1, and the columns with those leading 1s aren't a basis for the column space, and that's very clear if you think about it. But if you go back to the original matrix, this first, third, and fifth column, the ones with the leading 1s in the reduced matrix, are a basis for the column space. So the basis for the column space will be this. And we see that the dimension of the row space and the dimension of the column space are going to be identical, because every leading 1, well, every row has a leading 1, and every leading 1 gives us a column of the original matrix that's linearly independent of the others, and those columns form the basis for the column space. So if there are 3 non-zero rows, there'll be 3 leading 1s, and there'll be 3 columns that form the basis of your column space. Now that's row space and column space, and that's just kind of a review. What we're really after now is the idea of a null space, so we'll do that next.